Okay, now let's look at the last portion of the assignment. So what we've done so far is we've thought about our modeling. We've got Climate Consultant and Climate Studio that are both using the same climate files. We did a quick little check to see if we thought that they're coming up with the same information, because we always want to do that to be accurate, make sure we're being accurate. Beautiful things can be wrong. Then we created a flat topography and a test building and ran a bunch of radiation studies in our two climates to gain general information about how the sun interacted with a building or surfaces in those climates. We kept it simple so that we could really isolate the results, and we learned some things. Now we've chosen a site, and you've either built one yourself or you're building one over time. I'm not, I could see why it would maybe take you more than that 1 week. And you are, but you're building a site, you've got a site in Rhino, and now we're going to do some radiation maps as we're starting to adjust or think about how we might adjust the form of our building to maximize the solar resource in whatever climate we're talking about. So we need to understand, are we trying, so for example, I'm going to say right now, I want to think about how to, I'm going to think about, how, again, the south side of my building, or I'm going to have direct gain in this climate, and I want to see if this, and so I'm in New York right now, make sure that's right. Yeah. And I want to play around with the effect of moving my building in terms of sun hitting the south side of the building. And at the same time, looking at the other facings too, and trying to just start getting a little bit better at, or a little bit more detailed understanding of, or attempt at iterating my design, my proto design. So what do we have here? We have the site that I provided to you. I have applied materials to it, including, let's see, let's turn everything off. We have a site that has trees that have I put a material on, context buildings and a topo, so that's, we have, let me turn this off too. We have topography, some water, some trees, and context buildings. Then and those all have materials applied to them, and there are surfaces that have been added that I can add to the model. Then I have a project that I'm working on, this proto design. I have 3 different sightings that I'm going to play with here. The one that's just facing directly south, and well, it's long on its east-west axis. This is the south face. We know that because there's our compass down here. Be very clear with your compasses, by the way, if I haven't already said that. This is, if the compass is pointing this way, then this is the north face, right, on this side. Okay. And then I'm going to try 3 different sightings. One directly south, one if I shift a little bit to the east. So the south is now southeast and the south wall. And then one if I just place it completely back here in a different position, back to being directly having a south-facing facade, this one here, but it's set in the context of these other buildings. Okay, so I'm going to go to my results. I already ran all 3 of those. So what did I find out? And I'm going to do all hours for starters. Okay, so I have a baseline, and I think I've saved this over here. This is my baseline output. I've got 396 kilobTUs to the south, 254 to the east, 328 to the west, 135 to the north. Okay, so what if I I rotate this building 25 degrees to the east? What happens? Well, let's bring this in. and compare. I have now, uh, I was at 396 in the south, and I'm at 371, so I've dropped that number. I'm from 254 to 206 on the east. I've dropped that quite a bit, and I'm actually quite a bit more on the west, 328 before 381 now. Okay, so what would that tell me? Well, first of all, I would say I'm trying to get more sun into my direct gain mass just with no other information. That's not a good move. But then I think, wait a minute, I'm looking at all hours. Do I really want to look at all hours? And why does it say surface ground over here? You know, you got to start looking at the outputs. The reason why that was true is because when you mouse over surfaces in your model, it changes what's displayed here. It doesn't change the outputs down here. Those are set in stone in the model, but this is because they're totals. This is sensor based. Very interesting thing to do, but I want all surfaces. I'm trying to get it. Sometimes, yeah, sometimes it works, sometimes it doesn't. So, I mean, in terms, whatever. Yeah, I may not be able to have that sitting over here at the same time. Um, okay. So, um, so objectively, with all surfaces on, that doesn't seem like a good move, probably. But why would I just use if I'm thinking about the thermal mass direct gain? That's probably trying to heat up the building in the winter because I'm trying to get that low winter sun in there. So let me just turn on the cold hours and make a comparison. So this is the hours that are below 15 degrees centigrade. We could change this to IP, but I won't right now. Um, IP meaning that would be Fahrenheit. Uh, anyway, so let me try to bring this back. Okay, so now we have 396 to the south, only 170 to the south. Oh, actually, this doesn't really help anymore because this was total hours. So let's just go back and forth this way. We have 187 to the south in the cold hours in our original sighting, 170 in our new sighting. That's not an improvement if we're trying to get more sun in there. We have 85 on the east, 64, so a lot less. We're not getting more sun in. And on the west, we have 114 in the original and 148. So we're getting more western sun in the cold hours with our second sighting, uh, and less on the south and the east. So would that be good or bad? Well, it's going to depend on the context. So, for example, if our goal right now is just to get more sun into the building in the winter, um, objective without everything else the same, this would be a bad move compared to this site would be bad compared to this site. But let's say we had a bunch of obstructions to the south and east, or we knew there were going to be some obstructions, or we just wanted to think about what would happen with that. Then it might be better to have more sun on the west in the winter. Um, because then we can get some solar gain in through there. Now, that's a whole thing we really haven't talked about. With glass, um, you're going to get solar gain, and you're going to get heat gain from the sun, and you're going to get loss when there's no sun on the window. And the amount depends on what kind of glass you select, and everything is complicated. But just realize that that's really the dynamic here is that that a window is going to have either a net gain or loss over the year, and that's going to have to do with how much sun it lets in and how much is lost through the window when the sun's not hitting it. Okay, so so we don't really have a definitive decision there, but what we start thinking about then is how we might adjust our sighting based on the specific context of this of that's around it, and how it may not be the simplistic uh, ideal from our diagrams. Now we're in a real world setting and we're tweaking based on real context. Um, but then we might want to say, okay, I'm thinking, you know, if I've got some stuff blocking on the south and east, and then I would put that context in and see how much it blocked it. I could do that, but you know, just showing how this works. Let's look at the warm hours and compare those two sites. So now we're in the cooling season. We see that our south is 86 for the first site, 79 lower. So in the cooling season, lower is good. 65 for the east, 54 for the west. That's good. I mean, for the east on the second site, so it's lowering. In the west, is a little bit higher for the cooling on the in the heating season. I'm sorry, in the cooling season, but not as much as it was when we changed when we were looking at the cold. I think for the cold it was 148 for the second site and 114. That's a pretty big change, and so we were getting a lot more heat in there in the winter, and then we switch it to the summer. We're getting it's 103 to 108, so we're getting more sun, which is not ideal. But it's not as much more as we were getting in the winter. So we would take that into consideration. Now that's getting very detailed. I know you guys are beginners at this, but that's the idea. That's what we're doing. And at the same time, you're doing all the stuff you do in studio, all the other architectural considerations. But it's kind of obvious, I would think, that you need to do this at the beginning also, or you won't take advantage of your environmental factors. Let's just look at then the third site. Um, if our goal was to let me just turn this off and just switch to the third site. If our goal was to increase sun to the southern or increase solar gain in the winter, we could pretty much know this would not be a good approach because we're bringing a building in and into a situation where there's a bunch of buildings in front of it to the south, so it's going to be less. But how much less? I'm gonna go back to all hours. And we're at 218 for site 3 for the southern exposure, and we were at 396, so it's a lot less. Um, but so if we were going to go to Phoenix and we didn't want some sun coming in, we might want to consider this site, right? Because we would, or maybe in Phoenix we do want to use the winter sun. We probably do. So I'm not making any conclusion. I'm saying if we have two different climates, these two sites are interesting because they're very different. They're both facing the exact same direction in terms of the cardinal, the compass, but their context is different, and so they're having a very different radiation map. So that's the basic idea of what you were supposed to do in the last portion of the assignment. Just notice other things. A couple people said that they got the radiation map to work, but then when they were on the actual site, they weren't getting any change. So like they wouldn't get a change between site 1 and site 3. That has to be either that you're not applying the materials or you're not identifying surfaces in the run in the simulation for yeah, because for example, if we have for this the third simulation, um, it's important that these buildings were on and would have surfaces. If for the first sighting, if these buildings were on but they did not have surfaces defined, I mean we could have them on in the model, like like well, anyway, they could be on the model but not on in the simulation, and they would show up, but they would not change color and they would not affect the radiation map. So if that's happening to you, it's got to be, I would think, unless there's some other glitch, that you're not either applying materials or surfaces, and you're not putting the surfaces into the particular model. And remember, you do that by you turn on. Let's say if we want for siding 3. Um, I choose, I can turn on or off whatever. I could turn everything on in here, and then I could decide what I wanted to have in my simulation or not by what I clicked on. Notice also that we know that just visually that these trees are doing a lot because remember that these colors, have I said this yet before? The color range is coming from this section down here, and we can set this range. We can start it at 200 and change the range. Um, but you want to keep it the same for everything, I would think, just so we're comparing apples to apples, as we say. But what this is telling us is that it's much cooler underneath the trees than it is out here in the field. So these trees are definitely shading. Now, the problem with that, though, is that they're shading way more than the trees actually would. They're acting like actual built awnings. Whereas if these were deciduous trees, which they probably, well, might not be. I know this place and they actually are there, most of them. Then in the winter, they would actually lose their leaves. So this would be a completely different color. And I should probably have two different versions of the trees to show different seasons, right? So you can get into this pretty deep. Uh, All right, so that's the final portion of the assignment and of applying radiation mapping to your design process.